After a hefty snowstorm, flying balls of snow are a common scene across parks. But what makes a good snowball versus the light powdery snow that's good for skiing? It comes down to how much water there is in the air and what the temperature is. A small difference between these two factors can completely change how the snow consistency will play out in a winter storm.
Chatter about snow totals typically comes first when it comes to winter storms, but snow consistency is another trait of snowstorms that's not often talked about. The water content of snow greatly varies from event to event and can completely change the impacts of a winter storm. We often see two kinds of snow, the dry, fluffy kind that can be blown around, and a wet, heavy type that pastes itself onto trees, power lines, and buildings. The atmospheric conditions needed to produce these two snow consistencies can depend on where the snow is falling.
A lot of the time when we're talking about systems that affect Pennsylvania, we're really looking for the rain-snow line. And so the area at the surface where temperatures are going to be above freezing or, sort of down near the surface. And then there's generally a transition on the sort of at the beginning of storms. It tends to be more of the heavy wet snow and you got a lot of warm air coming in. You're going to cross over that rain-snow line, and the farther away you get from that warm air at the surface, it's going to become more of sort of a fluffy and dry snow.
Something that forecasters look for when determining what type of snow will fall is the snow-to-liquid ratio, which is dependent on how cold the atmosphere is. It describes how much snow may be produced given a certain amount of water in the atmosphere. For example, a 10-to-1 snow-to-liquid ratio means that for every inch of water, you would expect 10 inches of snow to fall. The higher or lower the ratio is can determine the type of snow that falls.
Generally speaking, 10-to-1 is kind of the average snow-to-liquid ratio that folks use. As you're getting up maybe towards 15, that's going to be more of your dry, fluffy. And then if you're getting, maybe lower down towards, say, 5 or 7-to-1, that's going to be heavier and wetter.
Snow ratios don't always stay the same throughout a storm, especially if the air temperature changes drastically, but there are areas across the Commonwealth that typically see higher snow ratios than other parts of the state.
Climatologically speaking, the highest ratios tend to be sort of Laurel Highlands and higher elevations in the Northwest Mountains, where more often the snow is going to be sort of lake effect, lake enhanced, which is sort of the drier, fluffier. Across the Southeast, where you get more of these nor'easter type systems, maybe closer to the rain-snow line, then your snow-to-liquid ratios are going to be below 10, maybe 7 or 8. But I would say, generally speaking, kind of like a 5 to 20 is about the range that we can see around Pennsylvania.
Elevation is a big component when it comes to general snow consistency, but seasonal changes in temperature are also a factor. Colder air doesn't hold as much moisture as warmer air, and this has implications for what the snow character will be.
In your coldest months, so January, February is going to be when you tend to see those higher rates, and it's generally sort of this lake effect or upslope snow that occurs, whereas your bigger synoptic systems, like for example nor'easters, are going to have the lower snow-to-liquid ratios, and that tends to maybe happen in sort of the front and back end of the winter, season, kind of November, December, and then as you get more into, March and potentially even April.
Another tool meteorologists use to forecast snow consistency is the dendritic growth zone. It's a layer in the atmosphere between 0 and 10 degrees Fahrenheit where snowflakes grow the most efficiently. With the right ingredients in the zone, snow can become slightly fluffier and snowfall rates can become very high.
If you have a lot of lift overlapping with that area of preferred growth, then it can lead to sort of what we call a thump of snow or significant snowfall accumulation, and is usually associated with some of our higher end mesoscale snow bands or heavier amounts of snow to fall.
Timing of such heavy snowfall can be one of the biggest impacts of a snowstorm, but the amount of water in the snow can change driving environments. Dry, powdery snow can have a tremendous influence on road conditions, even when it's not snowing.
If you've got windy conditions, even after the snow has already fallen, maybe it's blue skies and it's really chilly, but you might have snow drifts on the side of the roads, especially, maybe it's a big open field where there's a long fetch and a lot of wind that can blow across. That drier, fluffier snow is going to be able to blow onto the road. You can maybe fishtail or kind of spin out a little more easily if you got that dry, fluffy snow.
On the other end of the spectrum, wet snow can be tricky to clear both for plows and people, and it can have non-travel related effects.
Slushier conditions on roadways can kind of bog things down, especially when you talk about plows. because it's just going to kind of sit there. It gets slushy. It can even refreeze more easily. Wet pasty snow tends to be hazardous for shoveling in particular. We send out graphics every year regarding, increased risk of heart attack because of the strain that it takes to be able to lift even, just a few inches of snow when it's really heavy and wet versus the dry, fluffy snow that can just kind of be blown off. It also is a little bit, more of a propensity to put weight on trees and either break branches or knock over trees, which can then have downstream impacts on power lines.
Because of the unique characteristics that dry and wet snow have, the National Weather Service has created an index that can help illustrate how impactful a storm might be.
The Winter Storm Severity Index is a tool that's been developed by the Weather Prediction Center that takes into account a variety of different variables. One of those is snow load, and that's very much tuned to that snow to liquid ratio. And the more kind of heavy wet snow there is, that's going to ramp up the impact for the Winter Storm Severity Index because of the impact on the power grid and on structures as well.
Snowfall totals can sometimes be difficult to forecast, and the water content in the snow is something that can make or break that perfect snowball and how impactful a storm may truly be. For Weather World, I'm student meteorologist Brendan Pham.